Hi there, mathematicians. We are ready to start talking about volume. You're going to need this paper, a pencil, and 3 different highlighters. So go grab them if you need them. There's some in the tub in the room, as long as there's 3 different ones. And if you borrow, make sure you put some back. If you do have like a yellow marker or colored pencil, that's fine too, as long as it won't bleed through. So 3 different colors is the main thing. So the first thing we're going to talk about are attributes of these 2 shapes. That means properties. They're properties, they're characteristics. What do you notice about this shape or figure versus this shape? How are they different? How are they the same? So we're going to record a couple of those. So one thing is that this one has how many dimensions? It has 2, because it has one dimension going this way, use one of your colors, and it has another dimension going this way, and use one of your other colors. So highlight those now. And at any point, if you need to press pause, do so that you can make sure you have this recorded down as well. This one has more than just 2. You can see it's going back. It has width as well, and we'll record that. So it still has this one right here. So see how they're matching that dimension. And then this pink one is actually, that I did, is actually right there. And then we have our third new one, and that's going up and down. So what you're going to want to record is that we have a 2-dimensional figure. It's on a plane, a flat surface. So think of this as like a rug. And then you're going to want to write down that we have a 3-dimensional figure, and this would be like a box. It comes off that plane, off that surface. And so with that, you're going to want to write also down that means we have length and width. Right here, we use a cursive L for length, and then for width, we use a W for width. We use a cursive L so it doesn't look like a 1. And then this still has a length and a width, but that extra dimension is that height. We use like a cursive H for that height. Sometimes it can be considered depth, so record that down too, that we have all 3 of these. Depth would be like if this was the surface of the ground and then the swimming pool went into the ground, right? Height would be like a house or a building goes up into the sky, so you would consider it height. We most often will see sort of problems with height though. So what does this mean? This means we're talking about volume. Volume is the amount of space an object or a figure takes up. So this is covering, and let's add that. Area is covering a surface, but this is taking up space. Okay? So you can use, when you're thinking about how much space it's taking up, I know we've done volume with science, and that's of abstract figures and using a graduated cylinder and getting that displacement. But for a rectangular prism, we can use, let's write it down, unit cubes with no gaps or overlaps to find the volume. So if we can fill it with little cubes, we can find the volume, but this only works for the volume of rectangular prisms, because there's other 3-dimensional shapes out there, but it also works with cubes. Okay? So that's what we're going to be seeing with this lesson. Now when we have problems in different shapes of rectangular prisms or cubes, we could use a couple different formulas. So we know that we have 3 dimensions, but if we're given a situation like this, we can still find it in a couple different ways. So if we want to know the volume of this box, right, this whole thing, see it's filled with some Unifix cubes, but or unit cubes, but not all of them. It's not completely filled, but we have enough information that we need. I'm going to go back to my highlighters and I'm going to get my length highlighter. So I'm looking back up to which one I used. And where would length be on here? So it would be going across. And all of these parallel lines are also length lines that we can look at and view. Then I'm going to get my color that I used for width. So check out which one you used. And the width line would be like right there. But all these other lines that are parallel are also width lines. And then get your color for height that you used. And you can see there's a height of our prism too. So one of the things we can do, we have two different equations we're going to look at here. We can look at how many number of layers. So if you thought about this as a building, each of these cubes is a different layer. So how many layers does this one have? Should have said 1, 2, 3, 4, 5. It has 5 layers. And then we can also use the base or the area of each layer. So remember how length and width is area? So if we filled this whole thing, how many unit fixed cubes could fill this entire first layer? Well, we could use our length and width to figure that out. So we have 1, 2, 3, 4 going back. See how that's parallel to the width? 1, 2, 3, 4, right? So we would have a 4 by, what's our length? Well, it's not filled in right here, but we can look back here and see there's 1, 2, 3. So that's, our length is 3. So our base or our area of each layer is technically, I'll put a parentheses around it so you can kind of visualize that calculation. It's 12, right? So the equation can be written like this. It could be our base, or I'm sorry, yeah, our base times our layers. I use a capital B for base. Or you could, because it's multiplication, do repeated addition. You could do layer plus layers. Now it depends. We don't have 2 layers, we have 5, right? So if we were to solve this one, we would use 12 times 5. Or we would have done, so each layer, right, there's 12 plus 12 plus 12 plus 12 plus 12. Not as productive as this, right? So what does that equal? You do your 12 stacks in your head. That would be 60. And we would say it's 60 units, and we would use that 3, the exponent, because that means it's 3-dimensional. So you would say 60 units cubed, or 60 cubic units is how you can say that. And this, of course, would equal the same thing. So you could see the equations either way. So this is 1 and 2. Another way that's, I don't know, more classic, I guess, is looking at each of the dimensions separately and multiplying them. So you have a length, right? And remember, a length was how many? 3 unit cubes. And then the width was 1, 2, 3, 4 going back. But what was the height? Well, it's always the same as the layers. 5. 1, 2, 3, 4, 5. So there's your height. So your equation is length times width times height. So all you have to do is plug those in, right? What I want you to start recognizing, now these numbers are really easy, is that it's called the commutative property, that you can multiply these in any which way. I could do 3 times 4 and get 12 first, or I can do 4 times 5 first, and look and see which way would make your multiplication much easier for you mentally. Now, of course, you still have to write that work down, but I wouldn't have done 12 times, or done a 12 first. You can, but I would have made my life easier, and I would have done 4 times 5 first, because then that's a nice easy multiple of 10, and I can do that mentally to get 60. And again, units cubed. Okay? So we're going to be working with all problems that are going to give you different pieces of these information. So if they give you the base and they give you the layers, then you would be using this, right? If they give you all the layers, then you could figure that out by adding them all up. And then if you just have all of these 3 pieces, you could multiply them to get your volume as well. Sometimes we'll have missing information too, and you can use the inverse operation of division to figure that out. Flip your paper over and let's check what we have out on the back. So this is basically what we did here. We have these different formulas. The base times height, because of all of those layers. See how they're breaking that up? And then we have length times width as well in calculating that. So let's try a couple different examples. So this isn't just asking for the volume. I'm asking for the 3 different formulas. So what would they be? And it doesn't matter what order you write them in. What do you think they would be? So we already know the formulas with the variables of using like length, width, and height. But what would it be for this particular prism? So we would have 8 by 4 by 10. So that's using the length, width, and height. What other ones do we have left? We have base times the height. Okay. Well, that would be what then? The base has to be calculated. Which part is the base? Remember, it's that bottom face. So 8 times 4 would be 32 for the base. And then the height would be 10. The last one, which is no fun. Yeah, we're going to write it. 32 plus 32 plus 32. I don't know why I picked this one. It's torturous. That's already only 4, but I need how many layers? 10. But sometimes you will see this. A higher level thinking question would say, what are all the ways you can calculate the volume? And they'll surely have this one that you have to select. 1, 2, 3, 4, 5. All right, let's do 5 more. 1, 2, 3. I lost count already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy cow. Crazy. I'm even glad that we did this one because this is easy to do mentally, already calculated for us. So our answer is what? What's our volume? 320. Nice, easy mental math, right? So it's not until 6th grade that you get higher numbers and it gets a little bit harder. We'll see harder story problems with missing information, but it's not focusing on our calculation. It's focusing more on you using the right measurements, right? Notice I also use feet this time because the problem I'm using is cubic feet then. If they were just cubes, unit cubes, you would say that's when you just have the cubic unit. All right, last question, example, and then you're off to try some of these on your own. You have some information here. We still need to figure out the volume. What have they given you? Well, it looks like we have a 45, and it looks like we have a 4. Well, our length, what could our length be? Well, if it's 45, what are some options? What could that be? Because we do need to say that, and we need to calculate the volume. We can calculate the volume with what we already have, using our base times height. This is our height here, right? So 4 times 45, what is that? And if it is bigger, and you're like me, you like to see all that thinking, 16, 17, 18, you have 180. So we know the volume is 180. But one advanced question we could ask is, okay, but if it's 45, what could they be? What are some of the measurements that it could have been? Well, it doesn't look like it necessarily, but the measurements could still work out that you could have 9 inches for the length. But if this was 9, then what would this have to be? The width would have to be 5, right? Because 5 times 9 equals 45. No, it doesn't look like it, but it could be a 1. But then that means it would have to be a 45, right? Any other possibilities? Could be, depending on all the factors that equal 45, okay? So if you're given the base, you could figure that out too. All right, you are ready to start practicing and move on to your next activity.